Good day, everybody. My name is Honkit, and I'm the Cloud Security Specialist from Infoblox, looking after the APJ region. So today, the topic we're going to share with you, it's about DNS, or rather DNS-specific vulnerabilities, which can be exploited by the bad guys out there. And we're going to talk about how we can protect ourselves, just like the way we get, our COVID injections to protect our bodies. In this way, we also need to get an injection, right, into our IT systems, right, specifically DNS vaccination to protect ourselves against the bad guys out there. So the agenda we're going to cover today is briefly what is DNS, how DNS functions in a zero trust environment, the ways that DNS can be compromised, the DNS vulnerabilities and related attacks in the news, what should we do to protect our organizations, and lastly, we can end up with Q&A. Firstly, what is DNS? DNS is the phone book of the internet, where if you want to access a certain domain, like say google.com, you can just type google.com in your browser. But what happens behind the scenes is that each of these domains has a specific IP address, just like the address of your residence or your office. So in this case, google.com is 173.194.77.104. And in this way, the DNS server processes it and gives you back the result so that you can access google.com. So there are many DNS servers that stores all of these records for the internet. So anytime anybody wants to look up a name or number, and this DNS server will query their own records or other DNS servers where they need a record. So think of it as a bunch of yellow pages phone books strung together and connected to each other. I spoke earlier about DNS playing an important role in the zero trust framework. So I believe many of us know what zero trust is about, right? Basically, it's the concept of earning trust anytime and every time a resource accesses an IT system. So within a zero trust framework, you have several capabilities. You look at things like visibility, security automation, application access, micro-segmentation, foundational security, access control, and data protection. What I want to touch on today is foundational security, of which DNS is a key element, right? And the reason why it's a key element are two things. First, it is a central component of network and cloud architecture. The second, and possibly even more important feature, is that it typically lacks attention and thus lacks integration with today's cybersecurity architecture. And there is also a lack of visibility, into what's going on with DNS traffic in your organization, of which the bad guys can exploit. So I touch upon DNS being a potential weak spot in your environment. So since that is being overlooked because it's such a foundational protocol, when we think of DNS, we think of port 53. And port 53, in order to access the web or web domains, is typically left open and thus tends to be left under or unprotected. So you may ask, what are the areas where DNS can be overlooked or exploited? There are three specific areas that we should look at. One is something called flooding, right? So what is this term called flooding? So flooding is basically where specific DNS servers are targeted and attacked so that they can be prevented to record resolutions. So typically when we flood these DNS servers, the bad guys will use things like botnets, which are little scripts that are being run continuously and being run simultaneously so that they can flood and overwhelm the resources of the DNS servers, or rather the computing power of the servers that's providing these DNS servers. So when you have the bad guys that you send out these bots and you overwhelm those DNS resolution servers, right? That's the one where if you want to access google.com, they may have 100 million requests coming in to access all kinds of domains. And thus, the legitimate users who uses this DNS resolution server will not be able to use it. So another common flood attack is for DNS servers to address requests, right? For records that are either non-existent or invalid, so that there's no more resources to serve proper requests. Yeah. So this is more of I would say a mischief, or in some cases even an attack to bring down legitimate DNS servers. So the second example of where DNS servers are vulnerable to attack is something called hijacking, right? Also known as DNS poisoning or spoofing. So imagine a hotel guest which is given the wrong room number and a key. So this hotel guest goes around trying to open all the doors, right? And being led astray. So that's one example of hijacking in real life. So, but in terms of the DNS world, an example of hijacking is the act of entering false information, right, into a DNS cache, so that DNS queries will return an incorrect response and users are redirected to the wrong websites. So imagine if you want to go in, say, access a domain called example.com. If this DNS server that they are asking for resources to access that is being hijacked by the bad guys, they will be redirected to a malicious server that may look exactly like example.com, but has maybe tools behind to capture the credentials of the user as the user types in his credentials, or maybe asked to maybe log in with a username or password. So, and the DNS resolvers have no idea that all this data that is being planted in the DNS server are false, right? And there's no way to verify them as well. Yeah, so this is a very subtle manner of capturing, let's say, user information, in a malicious manner. So the third example, how DNS servers are exploited, is called DNS tunneling. And this is tends to be a little bit more visible in the news nowadays because it's talking about data exfiltration and stealing data. So how it works is that it uses the DNS protocol, right? The port 53, the traffic that goes through port 53. And the traffic that goes through there, if the hackers are utilizing this method, they would embed stolen little bits of data in each DNS query and being sent out to an external server. Besides external connectivity, hackers also set up a fake domain and a fake authoritative DNS server. So the way it works is when the resolution goes through and it passes through the DNS server, and this can be examined by a next generation firewall, which typically has no clue if the DNS data packet is malicious or not. And finally to a C2 server, which has been set up by the hackers themselves. So the nature of the DNS protocol, which uses UDP, allows this to encode data. That is how they break up data into small chunks, encode it, and send it out piece by piece, right? So within the name and label spaces. So that's why your NGFWs, IPS, your other tools that you typically have in your environment cannot detect this kind of stealthy and subtle way of exfiltrating data. So one example that we have of DNS vulnerabilities is something called RAC, which actually came out earlier this year. So in April 2021, there were 9 separate TCP IP stack vulnerabilities that were affecting DNS clients and actually jeopardizing more than 100 million IoT devices. So these TCP IP stacks are basically platforms that are used by a lot of IoT and even certain switches and routers. So one example is FreeBSD, which is actually used by some well-known vendors on their high-performance servers. Others could be NetX, which is used for IoT medical devices and printer systems. So you can imagine, how much patching effort you have to do just to protect yourselves against all these vulnerabilities. So, and some countries have taken effect to that. For example, the Cybersecurity Agency of Singapore issued an alert in April this year and asked everyone affected to immediately patch. And they are also vulnerable to DDoS attacks, right, or what we call remote code execution, right? That's where the botnet comes in. Yeah. So the pop quiz here is, what type of attack is this? I described 3 previously. And the answer is a flood attack. Yeah. So the thing about this is, in addition to patching, there's also no way of centralizing visibility and monitoring of some of these IoT devices, because by nature, they do not allow agents to be installed in them. So that is another challenge that organization out there who uses this technology and platforms would have to take into consideration. So this is something that going forward we should address, considerably. So another example of a DNS vulnerability that made headlines recently is something called Sigrid. So this happened last year, right? So on July 14, 2020, Microsoft disclosed a vulnerability in their own DNS server subsystem that affected all modern versions of Microsoft DNS, going back, I reckon, to the last 7 years. So from a CVSS score, which is basically the severity rating of a vulnerability, you rank 10 out of 10, which means that it is of prime importance to fix immediately. So why is it 10 out of 10? Because it allows the administrator domain to be hijacked and controlled by hackers. So once you are the Microsoft administrator, you can do lots of things. So this vulnerability affected all Microsoft servers from 2003 and up, right? Including currently supported versions at that time. So now, according to an article in the Cybersecurity Office issue, most of the endpoint detection response, proxies, and firewalls will not be able to detect this attack. So this begets the question, right? A Microsoft reputable DNS server can be vulnerable to something as serious as this. So the thing is your current DNS server setup sufficiently robust? Have you checked? Have you done the necessary updates and everything, right? So something to ponder about. A third example of a DNS vulnerability, and this one is targeting a specific geographic region actually. It's called Sea Turtle. So this was 2 years ago, and a hacking group called Sea Turtle carried out a campaign of espionage against DNS hijacking that was hitting at least 40 different organizations. So they were targeting very specific areas like the UK or the Middle East. So they were putting all the traffic of all the domains in these countries at risk. Yeah, so it's a multinational effort. So what they did is that they corrupted the internet domain servers that were running these systems, because you're looking at .co.uk, for example. So, and they were silently masquerading as a man in the middle at the background to intercept all this data so that they can collect it and send it to their own organizations for further exploitation. So this is what we call a classic hijacking attack, right? You believe that you are sending a query to a legitimate DNS server, and what you do not know is that in the middle, the data is being copied and stolen. So I just want to share a real-life example of what happened to these DNS vulnerabilities which are being exploited. So Infoblox did a DNS assessment, right? Assessment meaning that we come into an organization, by permission, we are asked to go through, set up the tools, and go through and scan all the DNS traffic that is going on to look for any signs of malicious activity, real or otherwise. So we did it for a prominent government agency in Asia Pacific. And we found that after 2 weeks or so of scanning, we found there were at least close to 9,000 examples of data exfiltration. Now, not all of them are of course, malicious, right? Some could even be legitimate. But we did find several attempts at exfiltration of sensitive data. Yeah. So it goes to show that even the government agency, with all its protections in place, can be vulnerable to something like that because the DNS protocol tends to be overlooked. And to further strengthen my message, the US National Security Agency has released a statement that says that secure DNS could reduce the ability of 92% of malware attacks to successfully deploy malware on a given network. Think about that. 92% of malware uses DNS to do their things. Yeah, right. So I think it warrants serious attention to address this oversight. So the next thing you might wonder, oh no, I didn't know DNS attacks or DNS-based attacks were such prevalence, and it's being widely practiced. But I don't think I'm adequate, or I don't think I'm sufficiently protected. What should I do, right? So the best practices are this. Look at deploying a robust DNS security solution to protect all your IP-based devices, including IoT devices, right? I mentioned the example of RAC. And security, as you know, one of the central pillars is threat intelligence. Use threat intelligence to stop communications between infected devices and malicious sites, C2 servers. Look at all the detailed threat information within context in seconds. So your systems and your solution should have the ability to process information very quickly within seconds, within minutes, not a few hours, not the next day. Another best practice would be to use something called a DNS firewalling. So basically, you're maintaining a set of updated DNS black and white lists, plus, and this is the key, plus real-time analytical tools, right? Typically using machine learning to detect and block DNS-based data exfiltration and DNS tunneling, right? So I already cited examples of how the bad guys can use these methods to come in and do their thing. So this is one key way of protecting ourselves against those methods. Integrate well with current security tools to ensure a holistic approach, right, to detection and remediation. So this is a classic defense in depth strategy. Last but not least, have some sort of a rule-based DNS DDoS mitigation. This is to protect yourself against flood attacks, right? Where I mentioned earlier that flood attacks tend to overwhelm your DNS resources. So this has to be integrated in both either your external or internal or both DNS servers, so you can keep your services running without being overwhelmed. Yeah. So the next step is probably, what should I do? So just like for ourselves, before we, fly to a new country or we want to do a visitation, it's quite often the rule and the procedure now to take a test, right? With an ART test kit or some other test kit to test for signs of COVID infection. So similarly, we at Infoblox would like our friends out there to start things off with a swab test, right? A DNS assessment. So what do we achieve or get from a DNS assessment? So when we run DNS assessments or swab tests, quote unquote, with organizations, with our customers, we find some interesting things. We may or may not, right? Depending. But if we do, then this is a sample of what we find, right? The amount of DNS activity that's in your organization, the amount of malware activity related to DNS or exploiting DNS, right? Any data loss. We also categorize into what sort of domains that the organizations users are connecting with, and we also have the power within our Infoblox solution to block DNS requests as well. Yeah, if any action is taken. One example of how we classify malware, right? So the popular ones are typically either data exploits or cryptocurrency mining, right? The more serious ones will be things like malware DGA. So DGA is an example of where the hackers actually automatically create several different new domains so that these domains will function as an external server to send and receive information, especially for data exfiltration, right? Other things could be like malware, could be ransomware, and on, right? So you get the idea, right? So you can see that, over the years, we've collected lots of information on the typical types of activities that these hackers like to do, and we have sized it accordingly. So with that, I would like to thank everyone for your kind attention and your time today to listen to me. I do hope that, as a closing, I do hope that you take what I've shared into consideration and think about it as a potential next step to look at protecting your organization and strengthening your defenses. Thank you, everyone. Have a good day.